Hello everyone. The title of this video is Solve Proportions. Each exercise I'm going to do for this video is taken from a free online textbook at openstax.org, and it's their Intermediate Algebra Text 2nd edition. I'm in section 7.5 titled Solve Applications with Rational Equations. And I'll be working on exercises under the heading Solve Proportions. These exercises are 253 through 262. Right, so 10 examples I'll be doing. And in the video I'll be labeling, example 1 through 10, and please know that example 1 corresponds to number 253, example 2 to number 254, and so on until example 10, number 262. And I'll have timestamps for each of these examples in the description of the video, so if you'd like to look at any particular problem, just go to that timestamp. Just count the number of examples that would be and go to that timestamp. One other thing I would ask of you is that when I bring up a new example, pause the video and try to work it out yourself first, and then watch me do it. Because if you're just watching me do it and not practicing yourself, you're probably not learning all that much. Okay, so let's get started with exercise 253, first example, example 1. Alright, so in this first example, and all the examples in this video, I'm asked to solve the proportion. And it's a proportion is just a rational equation. Alright, and hopefully you've seen my other videos on, this is section 7.5 of this text. I'm hoping you've seen section 7.4's videos I've put up, in which we solve rational equations. Alright, but a proportion is a special kind of rational equation. It's where you have just a single ratio or a single fraction equal to another ratio. Right, a fraction, say a over b, set equal to another fraction, c over d. And the way I would solve these is just like the way I solve any rational equation. Find the LCD, right? Find the least common denominator. Now for what I have written here on the right side of the page, that would just be b times d, right? Or just bd, and then I multiply both sides by bd, by the LCD, and that should cancel any denominators. The b's cancel on the left side, the d's cancel on the right side, and I'd be left with a times d on the left equals c times b, or b times c on the right. And you may have seen these before. You may have seen proportions before. What I have here now, the a times d equals b times c, these are sometimes referred to as the cross products of the proportion. As you see on the left, a times d, that's just the product of these two, or the numerator on the left with the denominator on the right. And the other side, b times c, that's the product of the numerator on the right with the denominator on the left. And you can see where the name came from, right? You're taking products of these things that are forming a cross, an X. And the a and the d would be called the extremes. The B and the C would be called the means. You may have heard this before as well. In a proportion, fraction equals fraction, ratio equals ratio. The product of the means is equal to the product of the extremes. Again, I don't care how you're saying that. And then, after multiplying both sides by the LCD, we'll then solve and, of course, check our solutions back in the original equation. Alright, so in this first example, now I know you could just multiply by 56, right? I'm going to go through this LCD procedure every single time. If you see a faster way that's legitimate, do it. Right? There's nothing wrong with doing it a different way. I'm just going to do it the same way every single time to remain consistent. So for this first one, x over 56 equals 7/8. The LCD would just be 56, right? 8 goes into 56 evenly. So I'm going to multiply both sides by 56. Right, we have x over 56 equals 7/8. And again, I'm multiplying both sides by the LCD. And the reason for that is to get rid of the denominators, right? On the left side, the 56's would cancel. On the right side, 8 goes into 56 7 times, right? So you'd still have a factor of 7 left over. And so now I have x on the left equals 7 times 7 is 49 on the right. And there you go. And then, of course, don't forget to check back in the original equation. Always check your solutions back in the original equation. 49/56 does indeed reduce to 7/8, right? Because 49 is 7 times 7, 56 is 8 times 7, and then the 7's would cancel, leaving me with 7/8 equals 7/8. So 49 is a totally valid solution here. Okay. Next question. Now, the first example, both these fractions on the sides were simplified already. The numerators and denominators of these didn't have any common factors. I'm going to make a little note here for example 2. I'm going to simplify fractions if possible first, because that'll make the number, it'll make numbers smaller. It might make expressions smaller. So I'm going to simplify some fraction, either fraction if they can. Simplify fractions, if possible, ahead of time, right? Or first. And then I'll go about finding the LCD and multiplying both sides by the LCD. Now 56. All right, 56. That's 7 times 8, 8 times 7, which is 2 cubed times 7. 72. All right, 72 is 9 times 8, 8 times 9. So these have a common factor of 8. Right, so 50, they would cancel the 8's, and I'm left with 7/9 on the left side. All right, equals, and then the other side is already totally simplified, y over 9. Right, and you see how that makes it a lot nicer. Right, the numbers are smaller. So if you can, I would suggest, you don't have to. Right, you don't have to do this. You can multiply by the LCD from the beginning if you wish. But if it'll make it easier for you, I promise to simplify the fractions first in the proportion and then do the LCD thing. I hope it's obvious now. LCD is 9. Multiply the right side by 9, the left side by 9, and on both sides, 9's are canceling, and you have y equals 7. Alright, y equals 7. And there you go. And don't forget to check, back in the original, 56 72nds is 7/9, right? You'd have 7/9 equals 7/9 there. That is making the statement true. Great. All right, and this is all I'm doing the whole time. All right, so next example, example 3. Same thing, the 98 over 154. 98 is 14 times 7. 154, that's 14 times 11. So you see that 98 and 154 have a common factor of 14. So 98 154ths reduces to 7 11ths. All right, so I'll reduce that left fraction. The right fraction can't reduce. So negative 7 in the numerator, p in the denominator. Alright, so the way this looks, right, the LCD is just 11p, right, 11 times p. So I multiply the right side by 11p, the left side by 11p as well. On the left side, right, the 11s cancel. The right side, the p's cancel. So I have just, on the left side, I have 7 times p equals, and then the right side, negative 7 times 11 be negative 77. And I want to get p alone, right? So now I'm dividing by 7, so that leads me to p equals negative 11, right? Negative 77 divided by 7. And there you go, there's your solution. Now again, please check it, right, back in the original. The left side was 7 elevenths, and then the right side, negative 7 divided by negative 11 would be positive 7 elevenths. You'd have 7 elevenths equals 7 elevenths. That is good. Okay, same thing here. Let's see if we can simplify 72 156ths first. Well, I know I can. They're both even at least. Alright, so let's do this. Break this up. No, I can't think. I'm not off the top of my head here. This is 2 times 36, which is 2 times 4 times 9, 8. This is 8 times 9, 2 cubed times 3 squared. Right, when you factor it completely. I know I haven't been factoring other things completely. 156. I mean, it's obviously a multiple of 2. I'm just going to do a little factor tree here. This would be 2 times 78. 78 would be 2 times 39. Alright, and 39 is 3 times 13. So 156 is 2 squared times 3 times 13. Alright, so when we're dividing these, you got some cancellations, common factors, 2 squared in the denominator, with, there's 2 cubed in the numerator, so 2 of those will go away, leaving me with 2 of the first. 3 in the denominator, 3 squared in the numerator, 1 of those will go away, right, because there's only one factor of 3 in the denominator. So I'm left with, in the denominator, 2 times 3, which is 6, and denominator I'm left with 13. Alright, so this fraction on the left simplifies to 6/13 equals, and then the other side, negative 6 over q. And now I'll do the LCD stuff. Right? So the LCD for this proportion would be 13q. Multiply both sides by 13q. Alright, on the left side, the 13s would cancel. I'd have 6q left. On the right side, the q's would cancel. You have negative 78, right? 60 plus 18, negative 78. And dividing by 6 gives me 13, right? We know from the earlier factorization here that 6 goes into 78 13 times. So q would be, negative 13, right? Negative 78 divided by positive 6. and please check, and that's good. It works. Great. Same thing every time. Alright, so now in example 5, the fractions are not simplified, or I mean they are simplified, I apologize. A is the only factor of this numerator. This has a plus 12, right? That's all one factor. That's as factor as that gets. So don't cancel the a's, right? That's not a times 12, right? That's not a product. That's not a factor of a. That's a term of a. You can't cancel common terms. That's bad canceling. So these are as simple as it gets. All right, so the LCD is just 7 times the quantity a plus 12, right? Just the product of those two denominators. And here's what I'm going to do now. I'm going to just write little arrows saying we're multiplying both sides, right, each fraction by this LCD. On the left side, the a plus 12s would cancel, and I'd be left with 7 times a. On the right side, the 7s would cancel, and I'd have 4 times the quantity, a plus 12. And don't forget the parentheses, right? That whole a plus 12 factor. Alright, now I'm solving this for a. Simplifying both sides here, and we distribute the 4. Gives me 7a on the left, 4a plus 48 on the right. Move this up here. Then I would subtract 4a, gives me 3a equals 48. And then dividing both sides by 3, get a equals 16. And then check it. Let's check it. 16 divided by 28. Yeah, that would be 4 sevenths, right? 16 is 4 times 4, 28, 7 times 4, reduced to 4 sevenths. This works. Okay. Very similar here. Both sides are already simplified fractions. The LCD would then just be the product of these denominators, 9 times the quantity b minus 16. And I'm multiplying both sides by the LCD. On the left side, the b minus 16s would cancel. I'd have 9 times b equals, and then on the right side, the 9s would cancel, and I'd have 11 times the quantity b minus 16, sorry. Distributing the 11 over here. Let me just take this over here. We have 9b on the left equals 11b minus 176. Subtract 11b, got negative 2b equals negative 176. And then dividing by negative 2 gives me a positive answer. Right? Negative divided by negative, and then 176 divided by 2 would be 88. All right, let's check this. If I had 88 in the numerator, and then 88 minus 16 would be 72, and 88 is 8 times 11. 72 is 9 times 8. The 8s would cancel. You'd be left with 11 ninths. This does work. Please check your result back in the original equation. Alright. I'm doing the same thing every time here. Fraction equals fraction, a proportion. Alright, so this one we have m plus 90 divided by 25, m plus 30 divided by 15. They're already simplified. Now the 25, right? That's remember how to find the least common. If it's 5 times 5. How to find the LCD? 15. That's 5. I'll line up one of the 5s here times 3. So the LCD is 5 times 5 times 3. Right? Is 25 times 3 is 75. Okay. So I'm multiplying both sides by 75. Well, let's put times 75 here on both sides, both fractions. Now, 25 goes into 75 3 times, so I'd have a factor of 3 left over, and then you still have this numerator. Now be careful, you have the entire numerator left, so it'd be 3 times the quantity m plus 90. Right, don't forget the parentheses there. And on the other side, 15 goes into 75, 5 times. So I'd have 5 left over, and then the numerator, and don't forget the parentheses, right? The quantity, the entire numerator, m plus 30. And now I'm solving this equation. Distribute the 3 on the left, the 5 on the right side here. So we have 3m plus 270 equals 5m plus 150. And I'll take all the m's to the left. So subtracting 5m would give me negative 2m on the left. And subtracting 270 would give me negative 120 on the right. And then I would divide both sides by negative 2 to get m equals positive 60. And don't forget to check it. The left side, you'd have 150 divided by 25. That'd be 6. So you'd have 6 on the left. And then on the right side, you'd have 90 divided by 15, which is also 6. You'd have 6 equals 6. This is a totally good solution. All right, same thing for number 8. The LCD, I hope you can see it, right? I'm not going to do this, like I did earlier. The denominators are 4 and 6. Both fractions are already simplified as much as they can be. 4 and 6, the least common multiple would be 12. Right? So I'm going to multiply both sides by 12. I'm just going to times 12. Now 4 goes into 12 3 times. Right? So you'd have 3 left over as a factor, and then the numerator n plus 10, right? The quantity n plus 10. Equals, on the other side, when I multiply by 12, 6 goes into 12 2 times. So you have 2 as a factor, times, and then the numerator, the quantity, 40 minus n. All right, now I'm solving this equation, then again, of course, we'll check our solution. Distribute the 3 here, the 2 here. This is 3n plus 30 equals 80 minus 2n. Adding 2n to both sides gives me 5n on the left. Subtracting 30 would give me 50 on the right. And then dividing both sides by 5, n equals 10. And then don't forget to check it. If n were 10, you'd have 20 divided by 4, or 5 on the left side. And then 30 divided by 6 on the right, which is also 5. You'd get 5 equals 5. That is a totally good solution. Right. So last page here, last 2 examples. Same thing. Now the left side is not completely factored, completely simplified. The left side, you have 2 that you can factor out of the numerator. 2p plus 4 would be 2 times the quantity p plus 2. Right? And then you have 8 in the denominator, which is 2 times 4. And then you can cancel the common factor of 2. Now the right side is already as factor, the numerator is as factor as it gets. The denominator you can write 2 times 3, but there's no factor of 2 or factor of 3 in the numerator, so the right side fraction is simplified. The left side fraction, though, simplifies to p plus 2 over 4. Right side fraction, p plus 18 over 6. Okay, great. So now, just like the problem in example 8, the denominators are 4 and 6. The least common denominator would then be 12. And I'm going to multiply both sides by 12. Right? Just going to write times here. Alright, so the left side, 4 goes into 12 3 times. You'd have 3 times the quantity, p plus 2. equals, multiplying the right side by 12, 6 goes into 12 twice, so you have 2 left over, 2 times the quantity p plus 18. I'm going to take this over here, distributing the 3, distributing the 2. Left side, you have 3p plus 6. Right side, you have 2p plus 36. Subtracting 2p gives me p on the left. Subtracting 6 gives me 30 on the right, and that's it. Please don't forget to check. Back in the original, right? If p were 30, you'd have on the left side, 64 divided by 8, which is 8. And then you'd have 48 divided by 6 on the right, which is also 8. You'd have 8 equals 8. That is a totally good solution. All right, and then last but not least, example 10. Both sides are fractions that are already simplified as much as they can be. On the LCD, again, pretty simple. 2 goes into 18 evenly, so 18 is the LCD. And I'm going to multiply, both sides by 18. Now on the left side, 2 goes into 18 9 times. So I'd have a factor of 9 times, and then that numerator is still left over, the quantity q minus 2. On the right side, 18s would just cancel, and you just have the numerator 2q minus 7. So no need for parentheses around that, right? You just have 2q minus 7, times 1. Right? 18 goes into 18 once. Alright, then we distribute the 9 on the left here. This would be 9q minus 18 equals, and then on the right side, still 2q minus 7. I'll take this up here. Subtracting 2q would give me 7q on the left side. Adding 18 would give me 11 on the right. Negative 7 plus 18. And then dividing both sides by 7, we get q equals 11 sevenths. 11 sevenths. Now let's check it. Left side, 11 sevenths minus 2. Well, remember when you add or subtract in the common denominator. So that'd be 11 sevenths minus 14 sevenths. That'd be negative 3 sevenths. Divided by 2 is the same as times 1/2. Negative 3 sevenths times 1/2. You have negative 3 14ths on the left. And then 2 times 11 sevenths would be 22 sevenths minus 49 sevenths. Alright, 7 is 49 sevenths. 22 sevenths minus 49 sevenths be 27 sevenths times 1/18 would end up being 3 14ths. You'd have 3 14ths on both sides. 11 sevenths is the good solution. And that's it. So once again, the timestamps and everything. Just example 1 is exercise 253. Example 10 is exercise 262. And I'm hoping that watching me go over these 10 examples help you out when you're working on similar problems. And thank you very much for watching.